You point your phone at a small black and white square. A menu appears. You order your food. You never think about that square again. It happens so fast that your brain doesn't even register it as technology. It feels like nothing, just a pattern, just a scan, just a screen. But that pattern was invented for a reason that has nothing to do with restaurants. It has nothing to do with your phone. It has nothing to do with the internet. It was designed to solve a problem on a factory floor in Japan. And the man who created it never expected anyone outside of a car manufacturing plant to ever see it. His name was Masahiro Hara, and in 1994 he was an engineer at a company called Denso Wave. Denso Wave was a subsidiary of Toyota, and Toyota had a problem. Here's the thing about a car. Every single vehicle that rolls off a production line is made up of thousands of individual parts. Engine components, brake pads, wiring harnesses, bolts, cables. Each one has to be tracked from the factory that makes it to the assembly line that uses it. And in the early 1990s, Toyota's tracking system was hitting a wall. The technology they relied on was the barcode. You know the barcode. It's that series of vertical black lines you see on every product in every store. It was invented in 1952 by Norman Joseph Woodland and Bernard Silver after Woodland drew it in the sand on a beach in Miami. The idea came from Morse code, dots and dashes translated into lines of different thicknesses. Barcodes worked, for decades they worked. They could encode a number, a product ID, a price. Maybe 15 to 20 characters of information. That was enough for a grocery store. It was enough for a library checkout. It was enough for most things. But it wasn't enough for Toyota. See, a barcode is read in one direction. A laser scans it left to right across those lines. That means the code can only be so wide before the scanner loses accuracy. And because it's one-dimensional, it can only encode so much data. Toyota needed to track not just what a part was, but where it came from, when it was made, which batch it belonged to, and which vehicle it was destined for. A single barcode couldn't hold all of that. So workers were scanning multiple barcodes on every part. Multiple scans, multiple steps, multiple chances for error. Masahiro Hara was tasked with fixing this. He needed a code that could hold far more information than a barcode, but it had to be scannable from any angle. It had to be fast, and it had to be small enough to fit on a tiny automotive part. Hara started by looking at existing two-dimensional codes. In the late 1980s, several researchers had begun experimenting with patterns that used both horizontal and vertical dimensions. David Alley at Interface Mechanisms had developed a system called Code 49 in 1987. Theodore Maimon's work on laser technology had made high-resolution scanning possible. The tools existed. But none of the existing 2D codes were fast enough or reliable enough for what Toyota needed. Hara's team needed something new, and the breakthrough came from an unlikely place. Hara was a Go player. Go is an ancient Chinese board game where two players place black and white stones on a grid, trying to surround each other's territory. The board is a 19 by 19 grid, and Hara realized that the patterns of stones on a Go board from a distance created recognizable shapes. Your eye could find the clusters. Your brain could identify the regions. What if a code did the same thing? What if the pattern itself contained markers that told a scanner exactly where to look, no matter how the code was oriented? That was the insight. Hara's team designed 3 large squares and placed them in 3 corners of the code. These became the position detection patterns. When a scanner reads the code, it looks for those 3 squares first. Finding all 3 instantly tells the scanner the orientation, the size, and the angle of the code. It doesn't matter if you scan it upside down, sideways, or at a tilt. The 3 squares are the anchors. The rest of the code is filled with a grid of smaller black and white modules. Each module represents a bit of data, a 1 or a 0. By arranging these bits in a specific pattern across the grid, the code can encode thousands of characters. A standard QR code can hold up to 7,089 numeric characters. Compare that to a barcode's 20. It's a leap of a different order. But Hara's team went further. They built in something called Reed-Solomon error correction. This is a mathematical technique originally developed in 1960 by Irving Reed and Gustav Solomon at MIT's Lincoln Laboratory. It was designed for correcting errors in deep space communication signals. The principle is elegant. You add redundant data to a message so that even if part of the message is lost or corrupted, The original can still be reconstructed. In a QR code, this means that even if up to 30% of the code is damaged, scratched, covered, or obscured, the scanner can still read it perfectly. Your phone doesn't care if someone spilled coffee on the corner of that code. The math fills in the gaps. In 1994, the QR code was born. QR stands for Quick Response, and it delivered. Toyota's factory workers could now scan a single code and instantly access all the information about a part. The scan was fast. It worked from any angle. It worked even when the code was dirty or partially covered. Production tracking sped up. Errors went down. It was a quiet revolution on the factory floor. But here's where the story takes an unexpected turn. Most companies would have patented this technology and charged licensing fees. Denso Wave did patent it. They held the intellectual property. They could have made millions. But in 1997, they made a decision that would shape the future of the entire technology. They chose not to enforce the patent. Denso Wave released the QR code specification as an open standard. Anyone could use it. Anyone could build scanners for it. Anyone could generate QR codes. No licensing fees, no permission needed. They published the technical standard and they stepped back. Why? Because Denso Wave understood something that most companies didn't. The value wasn't in the code itself. The value was in the ecosystem. If everyone used QR codes, then everyone would need QR code scanners. And Denso Wave made scanners. The more the standard spread, the more hardware they would sell. It was a bet on ubiquity over exclusivity. For years, the bet didn't seem to pay off. QR codes stayed mostly inside factories and warehouses. They appeared in some industrial applications. A few niche magazines experimented with them, but ordinary people didn't carry QR code scanners in their pockets. Then in 2007, Apple released the iPhone. The smartphone changed everything. Suddenly, millions of people were carrying a device with a high-resolution camera and a powerful processor. Software developers quickly realized that a phone camera could read a QR code just as well as a dedicated scanner. Apps started appearing. By 2010, QR codes were showing up in advertisements, on business cards, on product packaging. Marketers loved them. They called them the bridge between physical and digital. But adoption was still slow. Scanning a QR code required downloading a separate app. Many people didn't bother. The codes sat on posters that no one scanned. For a while, it seemed like QR codes might become one of those technologies that was technically impressive but practically ignored. And then came 2020. In early 2020, the world shut down. COVID-19 forced businesses to rethink every physical interaction. Menus couldn't be shared. Paper tickets couldn't be handed over. Sign-in sheets couldn't be touched. And suddenly, that little black and white square became the most important interface on the planet. Restaurants replaced paper menus with QR codes. Venues used them for contactless check-in. Governments embedded them in vaccination certificates. Payment systems built around QR codes exploded in popularity, especially in China and India, where WeChat Pay and Paytm processed billions of transactions through code scans. In 2020 alone, QR code interactions worldwide increased by 94%. Masahiro Hara's 1994 invention for tracking Toyota brake pads was now the backbone of global commerce during a pandemic. The man who designed it for a factory floor watched as his creation became the default interface for how humans interact with the physical world. And the most remarkable part, the core technology hasn't changed. The 3-position detection squares, the grid of modules, the Reed-Solomon error correction, the open standard, it's all the same. Hara's original design was so elegant, so well-engineered that it didn't need to be reinvented. It just needed the world to catch up. You probably scanned a QR code this week. Maybe to pay for something, maybe to see a menu, maybe to verify a ticket. You didn't think about it. It took less than a second. And in that second, you were using a technology born from a Go board built for a car factory, open to the world for free, and finally activated by a global crisis. The next time you point your phone at that little square, remember this. The most invisible technologies are often the ones with the deepest stories. And the things you take for granted were once someone's impossible problem. That square you just scanned. It took 26 years, a pandemic, and one engineer's quiet decision to give it away for free, before it became the most scanned pattern on Earth.